All right, so picture this. You've got a network, but there's no leader, no central server calling the shots, no one in charge. It's just this chaotic, ever-changing web of connections. So the big question is, how in the world do you know who to trust? Well, today we're going to dive into how military researchers are forging what's basically a digital compass to solve this very problem.
I mean, really think about it. Imagine you're in a disaster zone, or even on a battlefield. Your devices are all connecting on the fly, just creating this temporary pop-up network. A message comes through, but is it from a friend or a foe, a reliable device or one that's been compromised? In that kind of pure chaos, knowing who to trust isn't just a nice to have, it could literally be a matter of life and death.
So, to even begin to answer that question, we first need to get a handle on the kind of environment where this is an everyday reality. Let's step into the uncharted territory of what the experts call Mobile Ad Hoc Networks, or MANET.
So, what on earth is a MANET? You know, the easiest way to think about it is like a pop-up network. It's just a bunch of devices, laptops, phones, you name it, that automatically find each other and spin up a network right there on the spot. No cell towers, no central servers, nothing. And here's the kicker. Every single device is both a user and a router. It's responsible for passing information along for everybody else.
Now, these features make MANETs both incredibly powerful and, you guessed it, incredibly difficult to secure. I mean, on the one hand, you can set them up in minutes, which is perfect for military ops or disaster relief, but on the other hand, the whole structure is constantly shifting as devices move around, join, or just drop off. It's this dynamic chaos that really creates the fundamental problem of trust.
Okay, so if we're going to build a system that can navigate all that chaos, we first have to agree on what trust even is. And it turns out that really depends on who you ask. Researchers at the U.S. Army Research Lab actually looked at this from a bunch of different angles to build their model.
So if you look at it from a sociological point of view, trust is personal. It's that gut feeling, backed up by experience, that tells you another device in the network is going to do what you expect it to do. You're basically placing a bet on its future behavior. Economists, though, they see it a bit differently. For them, trust is the thing that lets you make a move when you don't have all the facts. It's that willingness to take on a certain amount of risk, to make a call based on the expectation of a good outcome, even when you know things could totally go south.
And then you've got the philosophers who make this really critical distinction. They separate the feeling of trust, your own personal attitude, from the objective property of being trustworthy. See, when you trust something, you're consciously making yourself vulnerable. You're accepting the possibility that you could be betrayed. And this little insight, it's absolutely key at building our compass. Okay, finally, let's bring it all back home to computer science. For a network, trust has to be something you can measure, right? So here, it's defined as a relationship that's built on cold, hard evidence from past interactions. Did this node pass packets along successfully before? Or did it drop them? This is data. This is something we can actually track and use.
All right, so how do all these big ideas actually play out in the real world of leaderless networks? Well, by mashing all these perspectives together, researchers figured out several unique properties of trust that are super specific to MANETs. Yeah, in a MANET, trust isn't a set-it-and-forget-it kind of deal. Not at all. It's dynamic, meaning you have to constantly update it based on your own subjective, direct experiences. That whole friend of a friend rule, totally out the window. And trust isn't always a two-way street either. But maybe the most important one here is that it's context-sensitive. I mean, think about it. A device might be fantastic at routing data, but absolutely awful at processing it. So you trust it for one job, but definitely not the other.
And this just brilliantly lays out that core philosophical idea we talked about, but now it's framed for a network. Trust is what a node thinks will happen. It's a subjective guess. Trustworthiness is what will actually happen. That's the objective reality. The whole goal of any trust system is to get that subjective belief to match up with objective reality as closely as humanly or digitally possible. So what happens when your trust gets it wrong? Well, if you trust too little, you get all paranoid, right? You miss out on good partners, and your whole network slows down. But if you trust too much, you leave yourself wide open to attack from a malicious or just a faulty node. Finding that perfect sweet spot, that's everything. So we've got the theory down, and we understand the risks. The next big hurdle is turning all this abstract thinking into something concrete, a mathematical tool, that digital compass that a device can actually use to make a decision.
And here is the really elegant solution from the Army Research Lab, a composite trust metric. It's smart because it doesn't just look at one thing. It combines two different types of trust. First up, you've got social trust. Think of this like a reputation score. Does this node play nice with others? Is it well connected? Then you've got QoS trust, or quality of service. And this is all about pure performance. Does it do its job correctly? Does it complete tasks without messing up? It's really about competence and integrity.
Okay, now for the final piece of the puzzle. We have our compass. So let's see how it's actually used to navigate a mission-critical decision in one of these tactical networks.
The process for using this compass is, when you break it down, incredibly logical. A new task gets announced, and any capable nodes can put in a bid. The leader then uses that composite trust metric we just talked about to figure out the risk of each bidder. And here's the really clever part. It doesn't just pick the strongest node. Nope. It picks the optimal node, the one that perfectly balances the chance of success against the risk of failure.
And this quote, this just sums up the entire philosophy behind the whole project. It's not about getting rid of risk completely. I mean, that's impossible in these kinds of environments. It's about managing it intelligently. It's a calculated trade-off, using a really sophisticated model of trust just to make sure the mission gets done.
So, while all this research was born on the battlefield, the implications are, well, they're huge. Just think about it for a second. If we can mathematically model trust in such a hostile, unpredictable environment, what else is possible? Could this same kind of thinking help us build more resilient financial markets, or more secure supply chains, or even more reliable civic systems? That's the powerful question this work leaves us to think about.